So Netflix price competition problem is a very well known as a famous problem. Now let's see how these matrix factorization techniques are useful here to solve this problem. So so the actually the problem that have the Netflix problem, actually the job is the task that we have to do, we have to predict the rating. Okay, we have to recommend it some movie to the user. That's the job that we have to do here. And the best is that we have to apply the collaborative filtering algorithm. Okay, collaborative filtering algorithm we have to apply on to it. And this competition has ended in 21 September 2019, and the grand prize that have got these guys Bel Carlos Jokes. I will actually in this video I have discussed from his research paper. Actually, I have taken the research paper and I have discussed on this video. Okay, they got this price, US dollar $1 million. They got by simple. By simple, they have applying the matrix factorizations onto it. Okay, now let's first see the data sets. So, what kind of data sets actually Netflix given to solve this? So, the data actually, actually the data sets is look like this. So, in the data, there I have 4 columns. Means first one for users, second one in which movie, and date of grade, and what is the grade actually they have given. Okay, this is the data, means the features of the data. Okay, and they have given the training data, they have given this much amount of training data, and these are training data rating that's given by this amount of users and this amount for these movies. Okay, these are the training data set, size of the training data set. These are the users, number of users. These are the UIs, number of users. There have the number of items. It means here instead of using item, it will be better if we write it movie M. These are the movies. Okay, movie J. Okay, so each users has given the rating from 1 to 5. In this way, they have given the rating. This much rating they have given. Our job is to predict it. The movie, those movie that all that have not given by the user. That is the job. I think you got the understanding the main concept. What is data look like? Okay, the training set they have given this much rating, including these. Just in yourself, just read this Wikipedia page. It will be far better. Just in easy language, they have written everything. Just read it once before solving this. Okay, and every data is available on Kaggle. You can using the Kaggle free account, you can download these data sets and you can apply it on yourself. Okay, now let's see how they have solved this problem. I have now in this video I have discussed it from his guy's research paper. Okay, I have discussed this. Okay, this is the references of this research paper. If you have time, you can read it. Now let's go there. So in the Netflix dataset, Netflix price datasets, there are two type of quantities. One is for user, one is user, and one is movie. Okay. Now let to understand these things. Let we have 4 users: user A, user B, user C, user D. Let we have taken 4 users, and let we have taken it. We have the 5 movies: movie 1, movie 2, movie movie 3, movie 4, movie 5. We have 5 movies and 4 movies. First, using this small amount of data, first let's try to understand this problem first. Then we have using this large amount of data, we will extend this concept on. Okay, so first let the user A given some rating on some movie. Okay, suppose let user A give the rating. Suppose let's say gives the 5 star, 4 star. Suppose let it gives the 4 star, 4 star rating they have given. Actually, we have seen there are 5 star, 1 to 5. Suppose let user A give 4 star, have give 4 star on the movie M5. Okay, and so if this happens, so the data set actually look like will be this, the matrix that is where in this data set there are 4 rows for each user. We have 4 user here. So this is for user A, this is for user B, this is for user C, this is for user D. Okay, and the column is responsible for each movies. Let this is for movie 1, movie 2, movie 3, movie 4, movie 5. Let this is now user A gives the 4 rating, means he gives the 4 rating on the movie 5. User A gives the 4 rating on the movie 5, so this cell will be now 4. Okay, this cell now will be 4. So if let some age users, suppose let's on this matrix age user given age rating for the age movie. Let, okay, now we will extend this concept on the further. So let first let age users give the rating for age movies. So if this thing happens, suppose let's take an example. It is, I'm using a white color. So suppose let first user give the rating, look like that the rating. Okay, so this means the user C give the rating 3 for the movie 4. This means user D give the rating 4 for the movie 1. User D give the rating 3 for the movie 2. I think you have understand the meaning of this table. Okay, now let's look into the details of this table. First look the details of this table. Just see this first row and the third row. Just visualize this row and this row. If you visualize this row, that means what? The user A and C give the same rating for each movie. Okay, this means that the age A row and C row are equal, means what? User A and user C give the same rating for each movie. That means the choice of the user A and C are the same. Okay, that means that that's recommend, that is actually at the end of the day we have to recommend something. Okay, if user A gives the same rating for each movie and the same rating also given by user C, that means the choice of the user A and user C are the same. So from that thing we can conclude that user A and C are choice are the same. Okay, now look into the another direction. Just see it, the first column and the for movie 1, let's see. I think it will be better if you're using the different color. Let these movies, first movie and the third movie. Let's see it. First movie and third movie. Just if you see this thing, sorry, fourth movie, I think it's my first movie and fourth movie. Let it. The rating of the movie 1 and movie 4 is equal. So rating of the movie 1, 3134, 3134. That means what? That means each users given the same rating for these two movies. So that means we can conclude that these two movies are the same type of movie. Because of this reason, says users given that same kind of rating. So we can, from here we can conclude that movie 1 equals to movie 4. We can conclude this thing from here, from this two column. Okay. Now let's look in differently. Means okay. Now look these three rows first. These B rows, these rows, and this row. This row. Let look these three row. These three row means just see it. B plus C. Then if you summed up these two B row and C row, then we got the T row. Okay, that means what? That means if you just write this thing, B plus C is equals to 4. Okay, that means, so from these things we can conclude that if B love, sorry, it will be D. It will be D. That means that if B love some movie and D love some movie, then D love some combinations of these movies. Okay, suppose let these things means B love, suppose let action movie. The rating of the B love, suppose if B love some action movie, and C love, suppose let C love some comedy movie. That means D loves action and comedy movie. That means D love action and comedy movie. That is the actual meaning about this three column. Okay. Now let's look into different angle. Look like different angle. Which I am using different color. Okay. So just now look this color. So just movie 2 look like the movie 2, movie 3, and movie 5. Look like this. Movie 2, movie 3, and movie 5. Now look like this 3. Okay. Inside same color. Now look like these 3 columns. That means what? Just if you averages, it's okay. 4, 8, 3. Okay. Instead of using, I think I am doing some mistake. These 3 rows are actually this one. Actually, instead of 4, it's my bad. Sorry for it's my bad. Here will be this value will be 1. Sorry, I mistake. So this color and this row are the same. Okay, so just see this now. Okay, sorry for that. It's my bad. Okay, now these three columns M2, M3, and M5. That means the average of M2 and M3 is equals to M5. That means average of M2 and M3 is equals to M5. That means what? That means the M5 movie. That means the M5 movie is the average of M2 and M3. Okay, average of means just see it here. If M2 movie is suppose let action movie. Suppose let it's this movie is a action movie. Let and this M3 movie let's it's a comedy movie. Comedy movie. Now M5 movie will be look like average action average comedy. It will be average action plus comedy. Okay, that's type of movie actually. It's average type of not so action, not so comedy. Average type of M5. That's true actually talking about. Okay, I think you got the idea. So now the question is so in the Netflix there have large amount of movie and large amount of customer. So it is not possible for a single users to watch every movie. So in such situations, our matrix will not be fulfilled by age data. Our matrix will not be fulfilled by age data. So let's look like this type. Suppose let this is our data set. In the data, we have these on the first movie 1, movie 2, movie 3, movie 4, movie 5. This is the for user A, user B, user C, user. If H, suppose if everyone give the average rating for H movie. Okay, let A give 3, 3, 3, 3. This one gives 3, 3, 3, 3. This one gives 3, 3, 3, 3, 3, 3. Everyone gave average rating for H movie. And some B will not give him any ratings on that movie M5 if this thing happen, if these situations happen. B is not given any rating for this movie 5, but H persons have given H movie 3. So what will expect here in such situations? We can expect that B must be given 3. B must be given 3 by mistake. Somehow it's mistake from our data, but its chances P is given 3 for this movie because everyone given the 3 rating for this movie. Okay, so because of this thing, we can conclude that since H choices is equal, means just see this data, H choices for here, H user choices are equal. So somehow here mistake. So we can conclude that since user H choices, user B choices, user C choices, user D choices are equal, and as well for H movies also they are equal choices. Some average value they have given for H movie. So in such situations, we can conclude that the user B must be given the rating 3 for the movie M5. We can easily conclude. Okay. So this is actually the average cases. Now the question is, if this thing happened from this here, suppose let from this data, here somewhere it is missing. The data there we have got here somewhere, this data is missing. Okay, how we'll expect what will be the value here? Suppose let this thing, let this mass, this field is missing. Let somehow one, now let's wait, let's remove remove this thing. Okay, now let how to we let somehow we there have no any data. C is not given any rating for this movie 5. Okay, we have to predict what will be the value of here. Now let's see, since A and the C's choices are equal, let's see, since A and C's choices are equal, since A and equals to C, rest of the movie, for rest of the movie, for M1, M2, M3 and M4, for these three movies, for this sorry, for these four movies, their choices are equal. So can we not conclude it? So C must be given the rating 1 for this movie M5. We must be conclude that, because for rest of the movies their choices are equal. So why not? C have not given 1 point for this movie 5. So because of these reasons we can conclude this thing. Okay. Now the questions, how do I figure, if we somehow, because this is a small matrix, we can, from this matrix we can easily find out these are the dependent from this column, dependence we can find out. But in the net, just see the Netflix data set, a huge large amount of data. The questions that comes into our mind for a large data set, how we'll find this value? The questions that come into our mind, how do we figure out all these dependencies for a large data set? How do we figure out all these dependencies for a large that is the question, big questions here. It is a small matrix, we can easily find out, but for a large matrix, how will we find out this thing? Okay. The answer that's now comes into our that answer, its answer will be simple. The matrix factorizations will give that answer. Okay, now let's see how this matrix factorizations come into the picture to solve this problem. Let's see it step by step. The answer is matrix factorization. Now let's see how this matrix factorization now come into it. So the matrix factorizations, so that helps us to given these answers. So first, going to the matrix factorizations, we have to know some features. What is the features? If you think this movie, so if you are guys are the movie lover guys, then you know what kind of features they are having in a movie. If you are guys are a movie lover guys, and I am not so much, so you can know very well from me. So the features of a movie, it will be a dramatical movie, maybe dramatical, or it may be a action movie, or it may be a comedy movie. For me, it may be a comedy movie, or it may be a scary movie. It be a, and the user choice. These are the movies features, and also they are have the for users also choice they are have, means the actors, which actor they are have in that movie, and what kind of means what kind of environment, means Type means I'm talking about the cinematography, that things means environment, just like kind of thing. Just assume yourself. Okay. Okay. So this kind of features actually we have. Now let's try to include this features concept into our movies. Suppose let's for easy of our understanding, let's we have considered two features. Means it's best if we'll do this two simple features, action and comedy. Let's we have considered into our calculation these action and comedy features. This action and this comedy. Let Now let's try to understand using these features how we will try to understand the each user's choices. What will be the choice of each user? Now let's try to understand. So here we have to consider two features, okay, comedy and action. These are the two features of our movie, and these two are the features of a movie. Features. There are many features. Just we have taken here two features. Okay. Now there are two things: the user and a movie. Now we have to predict what will be the choices of these users for a movie. Suppose let's consider I have taken some movie B. I am taking sorry a movie 2. I am taking consider, and user B I have taken sorry user A I have taken here consider as an example. I have user A and movie 2. So suppose let's this movie is a comedy type of movie means 3 and the action is 1. And some users give such kind of rating for this movie, and somehow we got it. Means the comedy for this movie too, we got this 3 rating, and for action purpose we got it 1 rating. Now we have to assume what kind of rating the user have given for this movie, and let we know that the user A are like comedy movie and he don't like action movie. We know user preference, every user has a different kind of preference. Suppose let we know we have some we user A like comedy movie and he don't like action movie. So because he like it, instead of using this sign here we have using as 1. Don't like 0. Now if we dot product these two things, if we make the dot product between these two things, means if we dot product 1 0 to the 1, then what we'll get? Then we got it this 1 into 3 plus 0 into 1, that means 3 plus 0 3. So we can now assume that we can now from this here we can conclude that the user A maybe give 3 rating for the movie 2, maybe give 3 rating for the movie 2. You can assume these things by sample. Since user A like, most likely he like comedy movie, he don't like action movie. So since movie 2 is already given by the others users 3 rating. Okay. So can we not assume since user A like comedy movie, he will give 3 rating as well. Since it is not like any action movie, so he would not give any rating for this action purpose. Only he gave 3 rating. So these things are talking about this dot product. Just see it. Just see it in practically. So just you are a user B. Okay, you are a user A. Okay, and you mostly like comedy movie. You don't like any action movie. And now you are going some cinema hall to show some movie that is already rated by 3 and in comedy purpose, and it is rated by 1 in action purpose. Since you like comedy movie, so you will give average comedy purpose, since it is average comedy movie. Since you have not like action movie, so you don't comment anything about the action. So simple. We can predict that you will give 3 rating for this movie M2. It's the simple. So I think you got the idea how this dot products comes into this purpose, in this purpose to predict this rating. Okay, now let's different another example. So let the same movie, let I have taken the another user B I'm taking, and let I am taking another movie 3. Let the user B like action movie. He like action movie and don't like comedy movie. He don't like it. The same movie. It will be better if you take the same movie 2. And the movie 2 is already rated by 3 for comedy purpose, and it is already rated by 1 for action purpose. Now what will expected from this user B? Since user B don't like comedy movie, he will give what? 0 for it. Since he like action movie, he will give 1 for it. So cannot we expect it? User B will give 1 rating for this movie 2. Can we do expect it? Means it is actually 0. He don't like it means it's a 0. Like it means 1. Just say this thing. Actually, if you multiply this, you got 0, and if we multiply it, you got 1, and summed up the same thing. Okay, I think you got the idea. So now let another example. Let I have another user and D. Suppose let another user D and another movie they have movie 3. Let the user D, it's like comedy movie as well as he like the action movie. Okay, both kind of movie he or she has liked. And the rating for this movies that we have got from the previous users, that's the rating for the movie 3 is 1. The rating for this for comedy purpose, rating for this comedy purpose for this movie is 1, and rating for this movie 3 for action purpose. Then what kind of can we conclude? Since each movie is already rated by previous users, 1 for comedy purpose and action purpose it is rated by 3, it is 3, then cannot we conclude that the user D also, since user D loves comedy and actions both, then cannot we expect he also give the 1 rating for comedy and 3 rating for means for or action. So because of that, we can conclude that the D user D maybe give 4 rating. It's all are the probabilistic thing. Maybe give 4 rating for the movie M3. Can we conclude that thing? Since he like it because of its 1. So because of if you multiply those two things 1 and multiply and summed up 4. I think you got the idea how this dot products has come into our pictures. Now let's the thing that we got. Now let's try to understand these things through a matrix format. Okay. So they have 2 criteria we taken here. The criteria, first criteria is comedy. Second criteria that we have taken action. In the whole discussions we have taken these 2 criteria. And suppose let's there have 5 movies we have in our these discussions. We have 5 movies. So let for this movie let someone give 3 for this movie. Means from previous users we got this data. For this movie we got 1 from previous users that already have the given rating, and based on that we are want to predict what kind of rating may be give by these users. Okay, these are the ratings that we have got from the previous users past history. Okay, this is 2, this is 1 2 1 4. Let somehow got this data. Now our job is Now our job is we have to predict. And for these two features also, you know, comedy and action, for these two features, and they are have how much users? 4 users we have taken here in that discussion. For these 4 users, the we know that the user A like comedy movie, he don't like, means it's better if I'm using the symbolically instead of using symbol. If like means 1 and dislike means 0. I'm using this symbol here. So suppose let he like here comedy movie, don't like action movie. He like here like let he don't like comedy movie, he like action movie. He like comedy movie, he don't like action movie. He like both. So in this situation, just see it. In these situations, the choices of the users A and C are the same. The choices of the user A and the choices of the user C are the same. Just see it. Okay. So from this thing, we can conclude that choice of A equals to C. Now, one thing we analyze the average choices of the B and the choices of the C will the average and the choices of the D are the sum. These are the thing I'm talking about. B's choice plus C choice is the same choice of the D, combinations of the these two. Means from these two things we can conclude that choice of B and C equals to choice of D. Okay, now let's see this thing, see these movie portions. So from these movie portions, can we conclude something? Can we conclude? Just see it first. Okay, now let's try to understand the matrix factorizations. Means from this user we got some idea what is the choice and how these things are happening. We got this kind of idea. Now using this choice and in this movie's previous rating, we have to predict which users are gap to which rating. Let's write it in this format. So first in this site we have taken the users. Suppose let for comedy I have using the word C. For actions I have using the word A. Don't be confused. This is for user A. This is for user B. You just see this is round sign B used for action movie. Okay. So let there have user A, user B, user C, user D. Okay, and these things for comedy, this thing for action, and we got it this value. This value he likes and don't like 1 0 0 1 1 0 1 1. We got it's the choices of this user. Now in here here we have two features of the age movie. Suppose let here we have 5 movie here. We have movie 1, movie 2, movie 3, movie 4, movie 5. 5 movie, and for each 5 movie we have two features, comedy or action, comedy or actions, and from the here we from the previous history we have known this how much points for each criteria, each features. So we got it for movie 3, P1, for M2 1 2, for M3 it's 1 4, for M4 it's 3 1, and for M5 it is 1 3. So actually just if you just multiply now these two matrix now for this thing, first thing, this one and this one, if we dot product these two matrices. If you make the dot product these two matrices, first this one means this column and this column, this column and this column. If you dot the dot product for these two things, then how much, what will got? We got it 3. Similarly for age rest of the elements, got it 1 1 3 1 1 2 4 1 3 3 1 1 3 1 4 3 5 4 4. Okay, so that means what? That means just pick up any element. So let's pick up 3. These 3 responsible for just make the dot product from this element and this element. We got 3. 1 into 3 plus 0 into 1. Got 3. I think you got the idea how this matrix comes into the to gauge the. So these are the things that we have got. Just see it. Just see it first. For a users look like this thing. These are the, if he 1031 look like this thing. 1031. He give the rating 3, and also here we expect that he also give 3. That's the thing. These are the two matrix that we have to. These things are actually called the user matrix. These matrix that we got here. These matrix we have to find. This is called the user matrix, and this matrix that we got from this matrix is the movies. Okay, our main job is to predict these two matrix. Okay, somehow, and that's to got these two matrix, the matrix factorizations concept come into the picture. Somehow you can predict these two matrix, then we can recommend something. Okay, now let's see how to predict these matrix. How we'll predict this. Now one thing we will analyze that. One thing you can, from here you can analyze that. We have seen that the choices of A and C are equal. Choices of A and C are equal. Okay, and now the rating. It's magic. They have rating also the same. Our guess rating also the same. Okay, since the choices of the A and C are equal, so can also the rating they have given also the same, similar. It's obvious. And the B plus C is equals to D, the C here. Here 1 plus 3 is equals to 4, 2 plus 1 is equals to 3, 4 plus 1 is equals to 5, 1 plus 3 is equals to 4, 1 plus same. Okay, that's the magic of this matrix factorization. Now let's see. Now let's in these directions. See this one. See this one. I think pencil. It's better. This pencil. Okay. See the movie 1 and movie 4. I think yes. Movie 4. Both are the same type of movie. And movie 1 also got 3 star in comedy purpose and 1 star for action purpose, and movie 4 also got 3 star for comedy purpose and 1 star for action purpose. Now let's see what its rating. So its ratings also all us the same kind of ratings they have got from each user. Let's see it. Since our movie 1 and movie 4 are the same kind of movie, so each users also give the same kind of rating for these two movies. Just see the ratings, right? 3311, 3344, the same rating they had got. Okay, these are the magic of the matrix multiplications. Matrix factorizations. Okay, that's thing that we have to apply to predict to build the recommendation systems. Okay. Now let's see. There have also another advantage for this matrix multiplications. The space complexity that we have faced in the first lecture, and we promised that how to reduce the space complexity by simple mathematical hacks. Now let's see how to remove this space complexity by simple this matrix factorization technique. Let's see it. So suppose let there have millions of movie and billions of users in the Netflix website. Okay, suppose let for ease of our understanding, some little bit data I have taken, some little bit. So let I have taken here 1,000 movies only. I've taken here 1,000 movies, and only I have taken here 2,000 users. It's some little amount. There are millions of users, millions of movies. Okay, last I am taking this is small amount of data, 2,000 user and 1,000 movies. So how much entry there are possible? So if you just multiply these two things, there are possibles 2,000 into for easy users, so 1,000. So it's approx it's 2 million entries here have 2 millions. Okay, but these small quantities they are 2 million entries. But now let's try to apply this matrix factorization. Okay, let's apply it. Suppose let this is for the movies. So for let they are have we have taken here we have taken how much features? How much features? 2 features only. Suppose let I have taken here 100 features. I think for this 100 features it's okay to summarize something about some movie. 100 features it's okay. It's maybe work finally work. So let we have taken here 100 features. Okay, and how much users here in these directions I have used here how much in this direction, sorry, in this direction I use here users. So here we have 2,000 users. So for this actually they have the time, these are the features, these are the features. Okay, and these are the users, 2,000 users and 100 features. So how much value it is possible here? It's possible 2,000 k entries here have 2,000 entries. Okay, now let's write here this movie part. Also for age movies we have to consider the same features, 100 features, 100 features, and how much movies we have? 1,000 movies. So how much quantities? So the quantities will be 100k entries. Take care. So if we consider this matrix, then we have to store 2 million entries. But if we somehow make this matrix factorizations, then how much entries we have to store? So just see it now here. In such cases, we have to store 2000k plus 1000k. So simple 300k, it's enough. It's enough. 300,000 k spaces is enough. So where 2 million? Just compare it side by side. Where is 2 million? Where is 300k? How much space we have reduced here by simple using this matrix factorization complexity? How much space we can easily reduce? I think you got the idea, guys. How can we factorize this matrix? If we make these factorizations, then our job is done. Dramatically, we got the best and best result. We can easily reduce the space complexity, as well as we can easily predict something about our empty entries. Okay, so somehow we have to doing this job. Now let's see how we will doing this thing. How we will doing this. Now the questions, the big question, the big challenging part is now how to find. So here I have taken the 100 features. The see one thing, 100 features. So elaborate a movie 100 features is sufficient. If you although if you taken here thousands features, that's not also a large number, okay, for these two quantities. But the main thing is here. So to how to find the right factorization, that questions, that now the big questions is how to find this, how to find that is the big questions, how to find this right factorization. Okay. So they are we have a system and we have a human. Now these things we have to do some iterative process. Now let's see it, how we'll do this very interesting thing. Now let's see it. So somehow we have to predict some randomized algorithm we will use here. Suppose we will use there, suppose it's better if you denoted these two matrix. Suppose this is the movies matrix, I am denoting it by simple M movies matrix, and I am denoting is for U, user matrix U. This is for user matrix. So let I will command something to the computer. Computer give me this, randomize this matrix and this matrix. First I am giving the command to the computer. Yes, computer gives us this matrix M and U, and now we will multiply these two matrix M dot U. Somehow we will multiply it, transpose something, multiply it, somehow we will multiply it and make the big matrix, okay. And also in the Netflix also gives us some matrix. Netflix also gives us, suppose let's take here this one, the matrix that is given by Netflix. Now we'll compute it. Now we'll compare these two matrix side by side, compare it. Now we'll find how much error we have, okay. So if we got a big error, then so we now will compare it. Now by simple computing it, we will find its error, how much error here I have. Now if we find a big error, then we'll give the command, no, we have to update this matrix. Training phase, this one actually called, we have to update this matrix. Some we have to update that, we have to reduce the error, and there have some process we all already learned, the stochastic gradient descent, how to update this a weight vector, we have seen this thing. So by example, if we have big error, then we have instruction somehow edit this matrix, reduce the error, and they by using these algorithms they had to reduce and change this value somehow and give some matrix. Now we will got some smaller amount. So that process we will repeatedly doing, okay. So until now we have not got sufficient amount of satisfactions, means close enough, means when this error approximately equals to 0, okay. Until now we will got this job. This is a iterative process, that things are called actually a stochastic gradient descent, stochastic gradient descent technique, that things actually called this thing, okay. These things are actually called the stochastic gradient descent. I think if you have any problem, please go there, solving the optimizations chapter. These things are called the stochastic gradient descent. Just see this chapter, stochastic gradient descent, then you can easily understand this process, how this updations is job at doing actually, how this training phase actually doing, how this things, this, and we can easily doing this by simple stochastic gradient descent, okay. So somehow, but the questions is how to compare this matrix, how to compare this matrix, this is the big questions. So because we have some because the matrix that we have predicted here, the matrix that have predicted here, every cell has some values, every cell has some value built up, okay. But the main problem is here, it is a sparse matrix, most of the values are an empty value, most of the value here, it is a sparse matrix, because in naturally when we use the Netflix data, it's not possible for each users to rating the each movie, It's totally impossible. Because of these things, here most of the elements is the empty value. So it is a sparse matrix that has been given by Netflix. So now we have to compare, we have to find the estimation error by simple the cell that have the rating values. The rating, here some value has rating. So we have to compare this value to this value. There's has already rating. Okay. So the error that we calculated, let's see to this another discussions. Okay, that is the thing that we have to find, and these vectors that we got, this vector, this vector actually that we have built here, this vector called the users feature vectors, this vector called user features vector, and this vector is called the movies feature vector. Okay, so yeah, we have to consider two features. So this dimensional is it belongs to R2. If we consider 100 features, is its dimensional for this vector dimensional will be R100. So it depends on the how much features we have to interest to consider into our algorithms. That's the thing. So now let we have considered, we have calculated the general calculation. This is I have taken some example. Now let we have considered, let we have considered f features. Okay, and the vector the vector, the features vector for user, the features vector for users is eu. It's simple, the features vector for user. Features vector for eu. Okay, so it's simple belongs to rf since we have considered f features, and the features vector for movie, let's item means pqi, means movie as taken as item. It's also belongs to our f. Okay, let these things. Now if we dot, making the dot product between these two feature vectors, these are the features vector, these are the features vector. If we making this dot product, then we got the rating for these users. So how we will got this, means if we consider this is a column vector, then we have to transpose this vector user vector. We have to make the transpose, means somehow any means if we consider, we have to transpose something, means somehow we have to make the dot product. Okay, somehow make to dot product. So the dot product will give the approximation results. So suppose let the rij is denoted the estimations result. Means the estimations result that will be given by some users u. Okay, so that the value, the approximations, this is the approximation rating, the user u rated of item I. So is let r hat, I have using r hat I, u means u for user and item ui, r hat ui will be what, here u I transpose eu. Okay, just if you see it from here, any one of them we have to make the transformation. So that things. Yeah. So it's the one, let's take, this is the approximation rating that users you have rated on that one item. Okay, Now, our job is to minimize this. Our job is to minimize this value, means some error we have to find. We have to error some find. And how we'll find this error? Means we have to compare this rating that has been already given by Netflix and that we have calculated, means the value that we have calculated from here. Actually, this value is RUI hat, and the value that have been given by this one is RUI, original value. Somehow we have to minimize this thing. Okay, so the objective functions that we got, the now the optimal problem that's come into the pictures will be like, we have to minimize, means arc mean, we have to find this arc mean, we have to minimize, and which things we have to find, predict, we have to predict this P and Q. This P means responsible for features matrices, this P is for features matrices for user U. Features matrix for U, for user, and Q is the features matrix for items. Okay, this features matrix, I'm talking about this matrix and this matrix. These things are actually movies. Actually, these are the, in Netflix they have this paper, actually this research paper, they have denoted this matrix as a, means for users they have P, for users they have used it the P, both are the same thing. P here they have denoted this matrix same as the Q. Okay, so we have to find these two matrices. At the end of the day, we have to find these two matrices P and Q. P and Q, we have to find it. So now to find it, we have to find the, like that, means we have to find the differences. We have to find these differences as possible as 0. Its error will be as possible as 0. So this value will be RUI minus RUI hat square with summations over those UI, those pair of UI, means those pair of UI where the cells is not empty. That's the first conditions, where the cell is not empty. So these things will be, it belongs to K, where K is the set of pair of UI for which RUI is known. Okay, means the training data that they have given, training data, that's simple, you can call it a training set that they have given, that's at the known. That's the thing, that's the objective functions we have to do. This is the main objective function. And also they have using to controlling the biases to avoid the overfitting technique. They have used some the hyperparameters, regular term they have added. Example, these are the EI and QI. I think you have known this one is known to us already. This thing we have seen, and this value is, we have regularized term already we have seen in the logistic regressions, linear regressions, SVM. What is regularized term? UI square plus PU square. Okay, this is the called the L2 regularizer. This term is actually called the L2 regularizer. This term actually called, means it to simple avoid the overfitting we have to use. So to avoid the overfitting, we have to use this is regularizer term. By sample the uses of it to avoid the to avoid overfitting. We will use this regularizer term. Okay, that's the objective function. That is the optimal problem that we have to use here. Okay, now there are various technique already solved. We have seen there have stochastic gradient descent, least square method. There are many techniques that are available to solve it. In generally, we have to solve this by sample using stochastic gradient descent. We have, if you have forget it, I recommend you, I suggest you please go to my the chapter of solving optimizations problem chapter. Then everything step by step I have already discussed this thing. Okay, these are the thing. Now the one thing here is important to know, the bias term. Okay, so what is the bias first? So let's try to understand these things, this bias concept through an example. Let's try to understand through an example. Suppose let the movie, some movie, suppose let's is better, it's a common known movie, Titanic. Let the Titanic is a very famous movie as well. So the overall movie for this Titanic movie, let the average rating, the averaging rating for this Titanic movie is let 3.7. They have given 3.7. But let there have some users, there have some biases for, there have some biases for each item, and let's call these biases for this item is bi, and also they have some biases as always for each user, and this user we call bu, bias of users, bu. Now the thing is, so since it's tend, the Titanic is a very famous movie, it tends to get 0.5, since Titanic is a very famous movie, its item they have a chance to get it more average rating from a users. We can expect it for a famous movie. Since Titanic is a famous movie, we can expect these things. So from this thing, we can expect it. We can expect the for this movie the bias time will be plus 0.5. But let there we got some users is a very critical user. Let the users that we have seen very critical user, very critical users. So in such users, what we expect? We can expect that for users they will give some. We can expect, since it is a critical user, we can expect from this user that he gave some low amount of rating for this high demand Titanic movie. Can we expect? It's natural. Suppose let's say I'm expecting here he gave minus point, this lower amount of rating from the original. So the main bias term here that we have to use, the bias term that we have to use the mu. So this average rating here, actually the authors are use this average rating as mu. This is bi, this is u. So these terms we have to add, mu plus bi plus ui. Okay, what will be this value now? Mu is 3.7, and this is a very famous movie. Can we expect for this item it will got plus 0.5, and the user is very critical users, he don't want to give some rating. So can we this type of got it? So how much value we can expect from these users to these movies? 3.9. It's fairly well. Okay, these terms we have to add in our approximation. So if we add this term to our predicted rating, now the predicted rating, now it will be ui plus mu plus biases for the item plus biases for the users plus the that already we have approximation rating. It's ui transpose pu into pu, ui transpose into pu. That's we can conclude. This will be our approximation rate. Okay, this will be our approximation rate. Now the optimizations problem that now it converted to. Now the optimizations problem. Now this optimization problem which converted to what will be the objective function now? Let's see. First, what will be the objective function? So now the objective functions here will be what? So the arc mean of we have to find what things we have to find. We have to find the p. First we have to find the p matrix. First then we have to find the q matrix. These are the matrix that we have seen. P for user matrix, Q for movies matrix, features matrix for user, features matrix for movies, and the B means this biases matrix. The B is responsible for these biases. Okay, this bias matrix. We have to find this argument, and now the problem will be same like this. RUI, that's are the given by Netflix, minus mu minus BI minus BU minus UI transpose EU. It's simple. If you just take it, I am rating these things. Okay, the whole square obviously. Plus this plus there have some regularizer term. What is the regularizer term here? The regularizer term is norm of PU square, norm of PI square plus BU square bias matrix, and it is a scalar quantity. No? These are the vector quantities, so we have to take its norm square. It's a scalar quantity. It's okay if you take in the single square. It's the scalar one. Bias for item. That's the thing. That's the objective functions. By simple using the stochastic gradient descent. We can easily solve this. That's the research. That's the problem that I have defined. From this. Just if you have time, please read this research paper. Okay. So these are the thing. These are the importance of the matrix factorizations to the Netflix recommendation system. That's a million prize. If you solve this problem, then you can got this $1 million prize. Okay. I think from these large discussions, you will got the idea how this matrix factorizations, why the importance of this matrix factorizations on the recommendations to build it. So actually, if I am right, then in today's world, the recommendation system, YouTube, the Netflix, the Amazons that we have in past lecture that we have shown you, actually they have used the matrix factorizations behind this. Okay, so it's depend to situations and what features they have doing. It's the company's internal matter. I'm not interfering this kind of thing. Just our motto is to understand how to use these matrix factorizations, beauty of this matrix factorization. By simple doing this thing, how we will easily solve this huge amount of complex problem. Okay, and not only complex problem, how much spaces we can easily reduce. Just see it. Here we have 2 million entries by this small number of data. But by using simple matrix factorizations, we will reduce this 2 million data to 300k data. Just see it. Okay. I think from these discussions, you got the idea how much importance this one is in real world. Okay. I think you will got the idea, you will understand this concept from these huge discussions. I request you, if you have any problem, please mail me, please comment below. Then I will try to give your answer as possible as I can.